Hi, I am Monjovin from Group 21. I and my groupmates will be presenting about the topic of smart package tracking system. First, let me introduce about the background of the system. With the advancement of technology has made people convenient in purchasing things online. People can easily use their smartphone to buy things in the online shopping applications such as Lazada, Shopee, Taobao, and so on. Therefore, the logistics service has played an important role in transferring the package from the seller to the hand of buyer. The number of courier franchises in Malaysia is keep increasing from 49 to 203 from the year of 2016 until the year of 2020. So, a reliable package tracking system is needed for the courier to hand off their package easily through efficient planning and shipping. Besides, the package tracking systems are also able to enhance the security by letting the customer know about the status of the package to reduce the risk of loss. However, the regional tracking system only update the location information from one warehouse to another warehouse instead of periodic tracking. Next, for the problem statement of the previous package tracking system. There are some functions are not included, for example, a real-time tracking functions and automated notifications. Most of the time, the package is easily lost or buyers will miss the time of collecting the packages if the package is not under a real-time monitoring by the buyer. The not collected package will either be sent back to the warehouse or it will be left at the doorstep of the buyer. Both of these situations are not convenient and with the risk of loss for the buyers. The buyers need to physically go to the warehouse to collect their package by themselves. If their package is sent back to the warehouse or if the package is left at the doorstep for a long time, the package might be easily get stolen. Therefore, the purpose of smart package tracking system is designed to help buyers to track their package record in real time and help them to choose their available time to collect the package to reduce the risk of loss. That's all for my part. I will pass to the next presenter. Thank you.
Good morning, sir. My name is Wong Jim. Now I am talking about the comparison of cloud technology. Cloud computing in 2021 has become the model of choice for information technology as company priorities service provider over traditional supplier in the wake of the COVID-19 pandemic. The rise for leadership in public cloud computing is a rise of three, such as Amazon Web Service versus Microsoft Azure versus Google Cloud Platform. They are leader in the infrastructure as a service and platform as a service. Now talking about the AWS Web Service. The advantage of AWS is the user need a stable, reliable service from a cloud platform with a long track record. Users are looking for more global reach. User need flexibility and a wider range of service. Users are in a large enterprise. The disadvantage is the AWS web service are more expensive in a EU location and the vendor specific solution. Besides that, I am talking about the Google Cloud Platform. The pros of Google Cloud Platform is the user company are already well ahead in digital migration. Users are developing and deploying cloud-based software and apps. Users are looking for a green tech solution. Users' website work within a hyperscale networking environment. The cost is the Google Cloud platform in EU area is more expensive, and without billing are very limited users. After that, I'm talking about the Microsoft Azure. The advantage of it is talking about a user are migrating to the for the first time, and user are the developer. Users are looking for a hybrid solution. Users' business apps and platform are Windows-based. The disadvantage is about the user need to manage Azure to make it effect, and speed can be an issue for some business. Now I pass to my teammate. Thank you.
This is our system architecture of Smart Package Tracking System. There are 8 components of AWS services in our system, which are AWS Amplify, AWS IAM, AWS Connector, AWS DynamoDB, AWS Location Service, AWS Geofencing, AWS Event Bridge, and AWS Simple Notification Service. Now let me introduce those services that apply in our system. First, AWS Amplify. User can create full-stack application front-end UI and back-end visually with AWS Amplify. It is also used to build, deploy, and host static website or web application so that user can connect web or application to AWS resources. Next, AWS IAM is provide fine-grained access control across all of AWS service. Top management or manager can specify who can access which services and resources and under which condition. They can manage permission to their workforce and system to ensure least privilege permission. AWS Connector is about the user sign out, sign in, and access control to the web and mobile application. Connector user pool provide a secure identity store that scales to millions of users. It also supports multi-factor authentication and encryption of data at rest and in transit. AWS Location Service enable users to add location functionality to their application, such as map. It provides affordable data tracking and geofencing capability and native integration with AWS services. While AWS Location Geofencing is evaluating a tracked device position relative to previously registered area of interest. User can add geofences around area of interest and store them in geofence application resource. AWS DynamoDB is fast, flexible, NoSQL database service for single-digit millisecond performance at any scale. It helps to execute the data with encryption at rest, automatic backup and restore, and guaranteed reliability with an SLA of up to 100% availability. Now, AWS Event Bridge is a serverless event bus service that can use to connect applications with data and variety of sources. It receives an event and indicator of change in environment and implies a rules to route the event to a target. The last one is AWS Simple Notification Service. It is a fully managed messaging service for both application to application, air to air, and application to person A2P communication. It connects with AWS Event Bridge service to send email notification to notify user. Now I'm going to explain the flow of system architecture or Smart Package Tracking System. First, the delivery company will use the AWS Amplify to create and build the front-end UI and back-end for their web system or application. Meanwhile, the top management or manager will give the permission to their workers to perform their access control in AWS resources with using AWS IAM. They will use the AWS Corridor service to handle the sign-up and login function of the user, and all the registration data will be stored in App DynamoDB. When a package is out to deliver, delivery company is able to view the route of package travel across the map in their system. The driver is also can perform real-time delivery and tracking when using this system. Now, geofencing service is important in this stage, as the geofences area can trigger the next service when the driver enter the areas. For example, when driver delivery a package from KL to Kampar, the geofencing service will trigger an event when the driver is within the geofences area, which is Kampar. And this is the event bridge service to help resist an event and apply the rules to route the event to a simple notification service. Therefore, the buyers can receive their email that their package is near. So this is how our smart package tracking system works. Thank you.
Hi, my name is Dang Wei Hua, and now I'm going to present the configuration in the AWS Cloud and also the Smart Package Tracking System prototype. So first thing I'm going to do is install the AWS Amplify SDK dependency inside the terminal of the Visual Studio Code. And after that, I will run the Amplify init to initialize the resource we're going to use in the cloud native application for the Smart Package Tracking System. And because of some configuration already added in this project before, so I will show the screenshot inside this video during our first time configuration. So when the first time I key in the Amplify init, they will ask us to key in the project name of our project, and after that it will show us some default setting for the project. For example, the editor of the project will be the Visual Studio Code, and the programming language we use will be the JavaScript, and also the source directory will be inside the SRC folder. And after that, we need to key in the access key ID and password. So we just need to wait all the things finish running, and we can see the project is created successfully in the AWS Amplify. So next, we will add in the AWS authentication by using the Amplify add-on to the project we created just now. So it will able to access to AWS Corridor pool for the user login. So the next thing we're going to do is add in the map to our project by using the Amplify add geo, else the map will not be shown in our prototype application for Smart Package Tracking System. After all the things are complete, we just need to push all our configuration into the AWS Cloud. So after push all the things, we are able to see the project we created just now in the AWS Amplify, and also the map we created just now in the AWS location service. The next thing we're going to do is run the Amplify console auth to direct us to the AWS Corridor identity pool. And after that, we will create on the edit identity pool to check the name of the authenticator role for our project. So we will be able to attach the inline policy for our prototype system. And now I will go for the AWS IAM service and create on the role in the access management, so we can search for the name of authenticator role. We copy from the AWS Corridor identity pool just now for our project. So after that, we can see there is the inline policy inside this authenticator role, and we have attached some of the policy inside previously, which allows the user to access to the AWS service. For example, the first policy is for the user access to the AWS location map, and second policy will allows the user to search their package by the tracking number, and the last policy will allows the user to track their package. So the next thing we're going to do is create the geofence for our Smart Package Tracking System. So we can see there are some geofence we already created previously, and there is also a add geofence button for us to upload the geofence file. So for uploading a geofence, we need a kind of file named geojson. So for this file, we need to go for the JSON IO website. So here will allow us to select the location we want. For example, now I'm going to select the ePort areas. So once the package enter this geofence, the event bridge will detect it, and the target AWS SNS service will send the email notification for the user when their package is almost reached this area. So now we're going to create the event bridge for our smart package tracking system. So we create our view rules here. So currently there are 4 rules we already created, but now we currently just need to use these rules for our prototype testing. So for the event pattern we select is the location geofence events, and once the package is enter the geofence we select, it will trigger the message to the SNS service to send the email notification. So this geofence ID is basically the geofence inside the location geofence, and the geofence I select for the prototype testing is the Toro intent, which is this one. So once the package is enter the Toro intent areas, SNS will send the email notification to the subscribed user email. So now I'm going to demo the prototype of our smart package tracking system. So we just need to key in the MTM start. So first thing we're going to do is create the account for our user login. So simply type the username, password, and also the email address. And after that, the confirmation code was sent to our email. Once we enter the code, the account will create successfully. So we can see there is a map for the user to track their package, and the search button here is allowed the user to search for their package, and the track button here is allowed the user to track for their package. So now I will try to use the AWS Cloud Shell to virtualize the path of the package moving. So I already created a shell script for virtualize the package location. I'm going to upload this one. Since I already uploaded this shell script before, so now I'm going to test it. So this script will keep updating the location for the package every 3 seconds. And after that, we go back to our map and see. We can see that the package are moving from here until here. So once the package reach the geofence for the Toro instance, the email notification will be able to send to the subscriber email for the notification. And that's all for our presentation. Thank you.